Well, hello, folks. I haven't really had a whole lot of time to do much, but got a little bit of time now, so I figured I would take advantage of it and do something that is sure to probably generate a lot of interest and a lot of messages. Hopefully, I can sit down today and knock this whole thing out. But something tells me that nothing goes according to plan. So without keeping the suspense going of what I'm about to put down, here it is. Don't ask me what it is. All I know is that it's a piece of military kit that's surplus, and it's weird and wonderful, and a donation for a teardown. And maybe I get to play around with it and see if I can't figure out what it really does, because I have no idea. Googling around and looking at these numbers, all we can possibly figure out is that it had something to do with the fighter aircraft, and that would make sense because we've got all these things that are wired down. So, I would tend to believe that's the case. But when it was handed to me, the person who donated this, he already opened it up, looked at it, saw a circuit board, and said, "I don't know what that is, but it just looks cool." And admittedly, it does look cool. We've got these switches on here, the whole ready, aim, fire, toggle. You got to flip the cover up so that you can't, that covers it so you can't accidentally bump it. And that's for zeroing something. And you got this to turn the thing on. And, this is all, quite serious stuff. You got this mode selector. You have to actually pull it in order to move it. And what's even more interesting about that is that it's got a series of holes through here, which I sort of speculated that for lack of having anything better to demonstrate it, that you would put some rod through this to prevent this from being moved into another mode, which is high power mode. So when it's in the middle, it's in a low power mode, whatever device we're controlling the mode of. Must have something to do with radio or radar or something, because we've got band, low power and high power. It smells, it sounds radio-ish to me, just because we have bands and we have low and high power settings. Sounds radio to me. So radar, who knows? I'm at this point, I'm just kind of making up a story that fits the facts, if you will. So, I really just don't know. There's not enough on the internet to really tell me what this does. So, somebody knows. I'd be very curious to know what it's about. And then you have this Ethernet RJ45 on the front. It's labeled ETH, I'm assuming Ethernet, with this cap. And that's wiggles around in this, so that's probably not watertight, which is probably the purpose of this connector. And it's new, so we still even have this cover on the multi-pin connector that goes out there that's labeled control. You got all these mounting holes and mounting points in the back and the sides. Just don't know what it is. Got a dimmer. I'm guessing it dims these indicators up here, or it dims whatever it's controlling. The control feels like a wire wound pot, so I'm gonna guess that that's wire wound. It just feels like it. It has that sort of raspy. Those of you that have Variacs will know what I'm talking about. When you turn them, that they have that sort of rough feeling that you can. That translates into your hand, you can feel. And this lamp test button here, which it actually takes a substantial amount of force to push these buttons. I mean, it takes a lot of force to engage them. And it's one the top of it, the front, is one solid chunk of milled aluminium, and the back is another solid chunk of milled aluminium. It's substantial. So anyways, I already loosened these up so that I could just, you know, whip the back off real quick and take a peek at what's inside of it. Again, it's been sitting over here for probably about 2 months, you know, under my bench here, you know, in a bin to you know, of stuff to look at, because I've got a whole bunch of stuff. Again, solid piece of milled aluminium, and there's the inside with the board, and there's the Ethernet cable that that runs from the front into an Ethernet. There must be an Ethernet controller in here. This is about as far as I've gotten. So now we'll go all the way. Actually pull this out, find out what's on the other side. So I know this is the boring part. Actually, watching me take stuff apart, it's not very interesting. But this isn't a production. It's just a dude with a video camera. I don't edit the stuff. I just throw it up as is. You know, it's one old dude in a video camera. So there's the Ethernet cable, and we got this DB25 with a wiring harness. We've got wax string. Everything's tied, neat, clean, sealed up, siliconed. Typical construction on a device like this. Spared no expense. Handmade. Probably the harness is hand wired. And that's interesting. I've seen these before. This is an entire Ethernet module, and I think it goes down to either RS-232 or RS-485. You write code for this, and it's displayed on a web page, if you will, or whatever it is. This is basically like an Ethernet to a serial converter, if you will. And you can write code for these. I've explored these, you know, for use in some projects. Never got very far, because usually what I end up doing is I end up just being lazy, and I end up just rolling my own instead of trying to figure somebody else's out. Maybe that's just me being too old school and doing and using what I know. You know, we're just getting an off the shelf you know, straight up Ethernet to serial thing. Because if I'm going to do Ethernet to serial, it's just literally going to be Ethernet to serial. Open up a port and you know, set an IP address and all that on a device, open up a port to it, and when, you know, connect to that, and then you just squirt data into that, and then that gets converted into serial data. It goes to your microcontroller, which I'm guessing that is. There's the MAC address, obviously, of the device. It's in XP1001.000-03. Have to look that up. Maybe I'll scarf that, or maybe I'll leave this alone. I have no idea what it is. Board's conformally coded, so I can't really read what that microcontroller is. MC9S12E. That's a Freescale micro. So there you have it. Had to scrape off some of the conformal coatings so that I could read it. There's not a whole lot else going on with this, really. It's a microcontroller and a Ethernet interface of some kind, and a bunch of switches. So all of this indication and switching goes up to this microcontroller, and we've got tons of just passives, and you know, we've got caps, resistors, the whole 9 yards. So this must be measuring something and doing something else, because we've got this multi-pin connector here that's labeled control, and we got 6 wires here. We're not even, it's not even using the all of the possible conductors on this multi-pin connector. There's only 6 of them there. It looks like maybe there's probably 15 or so, or 12 or 15 that can be used. 13. It's a 13, you know, 13 individual connections on that. So we're only using 6 of them. One's red, one's black, 2 are blue, and 2 are white, or one's white with a blue stripe, and the other 2 are blue with doesn't look like any stripe. So if I had to guess at what that is, obviously the red and black I'm going to guess are power, probably DC, just, you know, sort of a common sense thing. They're going right up to this DB25 here in pins, let's see, that looks like 16 and 3, and 16 and 3 on the board have big fat chunky tracks on them. So let's just assume safely, or you know, safely assume that that's DC input, whatever voltage, because you have no idea. Have to look at this power supply to see what's going on in there. We've got these buck converters on here, so it's probably, you know, getting it could be getting 12 volts, 24 volts, whatever, and then dropping it down to probably, you know, 3 or 5 or whatever you need for the logic. So if I was a betting person, I bet you could probably stuff just, you know, 12 volts into it, and that'd be enough to power this thing up. But I'm not going to do that without actually doing some measurements first and some, you know, looking around at the various parts. But then we've got the 2 blues and the white with the blue stripe. So we've got 6 conductors that are all going up through this harness and into this onto this board. There's a whole bunch of op amps on here. They've got op amps here. We got all kinds of op amps. We got 3 op amps here. You know, tons of passives, resistors, caps, transistors, you name it, they're all here. So it's measuring some, this thing clearly must be measuring some analog signal of some kind. And you know, how does this communicate? Does this communicate back to whatever device it's talking to? Because we've got control here. We've got this Ethernet here that goes through this Ethernet interface that's serial. That's clearly serial. I mean, I've heard of these before. I know it's got to be Ethernet, an Ethernet to serial device. You know, and then we have that Freescale micro. So is there? There's probably code on the micro running, and they can talk to it via Ethernet. For test purposes, probably. That's obviously not something that gets connected permanently. This is probably, you know, if it was in an aircraft, it's probably they go into the aircraft and they plug into it. You know, they plug a laptop into it. They flash it. They do some diagnostics. They look at some things. They set some parameters or whatever, and then they just unplug and screw that back down, and you're done with it. This is going to go to whatever we're controlling, because this is just the control panel, if you will, to the device. So this is probably looking at some analog stuff coming in, and it's probably, I would be willing to bet that 2 of the lines that are in here are probably some analog stuff, and then I bet the other 2 are probably some serial, maybe some RS-232 or RS-485, and we're squirting that back out to whatever we're controlling. So somewhere on here, I bet there's going to be a RS-232 or an RS-485 controller, and I'm looking for that now. And we got a Max 3070. I would be willing to bet. I'm not familiar with a Max 3070. I'd be willing to bet that that's probably RS-232 or RS-485. So what is a? Just look on my phone here real quick and see what that is. Max 3070. I know it's a Maxim part. ESD 15. ESD protected 3.3 volts. RS-485, RS-422. Controller looks like, just from the Google results. We've got the Farnell datasheet, which says that it's a RS-485 or an RS-422 transceiver. So there you go. That's how they're talking to it. That's how they're talking to it. It's 422 or 485 and whatever you know, we're controlling on the other end is obviously going to be the same. So there you have it. Not really a thorough reverse engineering of this, but you know, it would help to know what it is first, other than we know that it controls something that has bands and something that has power. So we're taking all of these inputs, and you know, it's clearly to set something up. You know, we've got these 0 things going on here. We've got 2 of them, and why would you have 2 of these? So it's for multiple things. I don't know. I'm just speculating at this point. So now that I've given everybody a taste of this, they're probably going to start. People are going to start screaming at me in emails now. Hey, well, what is it about? Because I'm getting emails about that GPS module. Hey, you know, what's going on with that? So many projects, not enough time. So you know, I got to do the work that pays the bills. So anyways, I'm probably gonna pull some stuff out and you know, set some stuff up and look some stuff up, and probably throw another video up, and you know, of me attempting to power this thing up and probe around on here to see what interesting signals we have. So anyways, guys, while I do that, look at this, and then maybe you can tell me what it is, and I'll know what to probe for. Anyway, guys, hope that was interesting. Take care of yourselves. See you next time.